This video is the third of a series intended to explain the fundamentals and use of root cause analysis in food safety management, specifically the HACCP system. The focus now is on the components of most root cause analysis, RCA methods. The idea is to explore each component to make better use of them in food safety management. Most techniques agree that a well-defined problem makes the analysis easy to complete. Defining the problem can be facilitated by using the 5W1H technique. The why may help to establish the first elements of the chain of causation. Some software uses the statements made in the problem definition as a basis to start creating causal trees. The next component is categories. Categorical thinking is not used by all types of root cause analysis and is criticized by some of them. Defining categories of causes helps to guide brainstorming in ensuring that all aspects of the process or system are being considered. Some users adjust the categories to causal factors. Some categories are also considered noise factors or sources of variation. Their number varies with the context. Typically, the letter M is used to memorize them. In the beginning, there were only 4 M, because Dr. Ishikawa did not think that humans and the environment were significant categories. But soon thereafter they were added to the list, and the 6 M were created. Some users prefer to add money or management to the list. Other users prefer the letter P and deal with 6 or 8 categories. Categories with the letter S can be used to solve problems related to services. The RCA model proposed by the UK Food Standards Institute uses the PEM-PEM acronym and separates utensils from equipment into different categories. A recent automotive industry guidance for improvement relates the Ishikawa categories to 4 work elements, sources of variation, and noise factors. This can be useful to integrate various analyses. Some techniques call for a structured approach to RCA in addition to categorization. They suggest dividing the causal chain into symptoms, first-level causes, high-level causes, and root causes. Higher-level causes can also be called underlying causes or factors. There are at least 3 types of these factors: performance shaping, contributory, or causal. The previous video mentions how events are related to causal factors using the ECF technique. Some proposers of this method use a predetermined list of probable root causes for each group of factors. Causal factors may take different names. Performance-shaping factors are used for factors related to humans, and contributory factors are used for factors related to foodborne pathogens. Some RCA frameworks suggest reinforcing the analysis with a good understanding of human factors engineering. Human factors are also considered contributing factors. The existence of a root cause is debated by the proposers of some techniques like the Apollo RCA. This is based on the understanding that the chain of causation can go to infinity or end in God. But for RCA, the interest is in the segment of the chain of causation that can be controlled by the operation. The concepts of spheres of control and influence become useful in this case. Another way to realize the practical use of the concept of root causes is by looking into the concept of failure chain used in failure mode and effects analysis, or FMEA. In this case, the analysis is focused on failure modes and functions, but the identification of causes that are close to root causes is key to the proper application of controls. A new concept that facilitates the identification of root causes is that of failure mechanisms. Mechanisms differ from modes because they explain the processes in which a failure occurs. Examples of these phenomena include the corrosion of metals and the hardening of elastomers, or rubber. Automotive industry guidances also identify 3 types of root causes: occurrence, escape, and systemic. They are identified at various levels using the 5 whys technique. Occurrence causes are the technical issues that cause the problem. Escape causes are related to the inability to control or detect, and systemic root causes are related to the ability to anticipate. Occurrence and escape root causes can be easily understood by relating them to the structure of an FMEA. These 3 types of root causes illustrate the importance of solving a problem at all levels. In short, a list of common components of an RCA can be established by looking at the similarities between the methods. The list includes effects, categories, causal factors, and root causes. Properly understanding the concepts of causal factors and failure mechanisms can ease the identification of root causes. Thank you for watching this video. The author will be happy to collaborate on projects related to these ideas.